Okay. So I am here to talk about intake. For lots of people that haven't heard about it, this might be the first mention of it. I will start by saying, what is it that inspired this package? Where does it come from? What's the problem that it's trying to solve? And there'll be a pseudocode-ish demonstration of how that problem can look to various people within an organization. I'll take you through that, and I'll try and explain why intake exists and what it does. And then in the middle, there'll be a fair number of what I've called case studies. So these are specific things that in your day-to-day life, as working on some person who is connected to data in any way, which is basically all of us, there are specific things that you want from your data system, and I'll show you the kinds of things that intake thinks about these, what intake does for you. And then I'll just list basically all of the things that you want your data system to be able to do, and I'll claim that intake solves all of your problems for you. But the real point here is that you should go away, read the documentation, install intake, try it, get in touch, and then together we can make a data solution that makes everybody's lives easier. So a little bit of getting started. This is quite funny here, because we were just talking about Anaconda and XL. But some time ago, here I've said 20 years. There's a little picture of how 20 years ago looked, for those that remember that. 20 years ago, basically, data analysis meant working in Excel. For most people, you could say at the time, if you wanted to have something that was structured, a large amount of data, if you wanted to be more rigorous and programmatic about it, basically you'd have to go to SQL. That was the only solution back then. The reason that the way things were being done was bad from a modern programmer's point of view is that you have all your data is just there, it's on this layout, you have all your formulas are in there too. It's very difficult to know what leads to what, to track the computations that are happening. And these final 2 points here, which it happens with notebooks, it happens with code too, but it was particularly bad with where you have your data and your calculations mixed together. You save a new version, you just give it a new name. Now you have 30 of these things and you don't know which is which. That's extremely typical. And if you want to share this with somebody else, you literally send them a copy of it on email or like a disk or something. So those things are obviously problematic. I don't need to talk about that. And we've moved on a lot. So this is a more recent, very popular film. Apparently the highest grossing of last year. Now, 20 years have gone past, and yes, sure, lots of people still use Excel. I'm not saying that Excel has gone away. That's not the point here. But there are lots of different types of data out there. By types, I mean it can be tabular or array-like or event-like or basically anything that you can think of. Also, this data has massively grown in scale. Loading it into the memory of some application just isn't going to work. And you're not going to fit it into the memory of a single computer at all in many cases. And that's only intermediate data. When other people think about big data, they mean really big. So the kinds of thing that you need a dedicated data warehouse or actual facility to store the stuff. Which means that the storage is no longer on your machine. And the things that you're doing with all of this large heterogeneous data has also changed a lot. It's now really complicated. Now you're doing neural networks at the simplest level. Maybe you're doing lots of different things. I don't need to go into that. We have a whole track dedicated to it. Also, another change is that people are now programming in Python. It's the #1 language that people are learning, particularly in data-related things. Data science courses are taught in Python. We like Python. At Anaconda, we like Python. And data is used in all business, all science, all government, everywhere, data, data, data. So intake is going to help you with getting at that data. This is basically what intake does. Here is the documentation page. You will have seen the logo. You all have nice stickers in your welcome brochure. Feel free to stick them onto your laptops if you feel like it. Intake is a package that is being developed by Anaconda. It's free and open source, and it enables you to search through the data sources that are available to you and load those data sources without having to know all the nitty-gritty details. I'll demonstrate in a moment what that means. It comes with this idea of a thing called a catalog. A catalog is a prescription of the data that you have available to you. And catalogs can be lots of different things. They can be a file with a set prescription. I'll show you that. But there are other kinds of catalogs that I'll allude to later. And hopefully, at the end, we can talk more about what exactly a catalog can be. For the time being, just think of a catalog as something that points to specific data sets and tells you how you go about loading that thing. OK, so in talking about what is Intake actually solving for you, I first want to mention that when you talk about data, we talk a lot about data scientists, but actually there's a whole data team. And if you're at a small enough institution, then maybe it is actually a single person that's doing all of the roles in front of you. But as you go to a large corporation, for example, you will have people who do data science. You'll have people who write code. You will have people that maintain the repository of data assets, so the curator, I've called it here. You will have people that care about the integrity of the system and security and deployment and all that kind of thing. And of course, you'll have people that just want the outputs of the analysis and don't want to know anything about how it was created. Intake hopes to fill in the gaps between these things, give everybody a common language for talking about the data sets, and so streamline the whole process. Let people get on with the job that they're supposed to be doing. Now, who has written a code cell in a notebook or perhaps a script that looks something like this? Hands up anybody who's done that. That seems to be the majority of people. This is obviously not quite real, but it's very realistic. Let's have some CSV files. It's on some server. I need some credentials. I'm going to load them, and at the end of this cell, I have a data frame. Now I'm ready to actually do some analysis on that data. From the point of view of the people that I just mentioned, there are lots of problems with this here. It's a fine thing to do, and we're all going to do it at some point, but it's not the best solution. So why not? Data user, which is probably the data scientist, the person who wants this data frame, do they really have to, for every data set, figure out what code goes into this cell? That's a bit of a pain. And indeed, these are just file names on some server. They probably copied this code from their neighbor to figure out which data set is going to solve their problem. It would be much better if you had a way of knowing which data was which so that you can find the particular set of data that solves the problem that you want to be dealing with. From the point of view of the provider or curator, that is the person that's put these files into that place, it might not be the right files to use anymore, and they have to somehow tell the data user about this. That doesn't work if they're copying this code from somebody else because they're not in the loop. They need to be able to tell people there's an update, and also this update might actually need different code to load it because it's being stored in a different storage service or it's a different format or whatever it may be. IT users, the IT management point of view, this is really bad for them. You shouldn't be saving your credentials into your notebook, right? There should be either you have to type it in every time. That's a fine way of doing it. That's a secure way of doing it. Or you should have some service that can fill that in automatically through some single sign-on. That's what you want. And this is a real problem, actually. Now if you have people copying stuff that has credentials in it, now you don't even know who's accessing the data. So this is really bad from their point of view. And then we have the developer. We just said, oh, we've changed the actual format here. Now it's going to be in something else. But actually, that something else doesn't have a reader yet. Can you make something that reads it? They need to start from scratch and really understand what it is that the data scientist, the data user wants from this. Or they're going to have to find some other package and link it into what they're doing. It's a bit of a pain. And in particular, if you actually are swapping storage service and data formats, all of these things, the dev is going to need to do work every time, and that's a pain for them to do custom work all the time. So in intake, this same code cell looks something like this. This is an example. I am referencing some file. This is the YAML spec for intake is a very simplistic declarative way to declare what your data set is. And you can store all those details of how to load the data in some file so that the user of the data, they just do this line. They just say read, and now they have the data. They don't need to worry about what that stuff is. And that's very important. It means that this code is shorter, and you've abstracted away, you've separated the concerns of the person who's going to author this thing that I'm going to call a catalog from now on, and the person that uses the data that doesn't need to know, so they just get on with their life. Okay. Now I'm going to list some things that you want from a data service, and intake does these things. And demonstrations are going to be in the documentation, but really the best way to feel this is to try it out yourself. So the first one, I already mentioned this a few times. Copy and paste is bad. It's bad. So don't do that. In this, by using intake, you abstract away all of this nasty, gnarly stuff into something else so that the user doesn't need to do copy and paste anymore. They have a consistent way to always get at their data. Second thing, if you're going to have a declarative language for your data sets, and YAML is the default one that we use within intake, then you have something that looks like this. This is a real data set. It says there is some CSV file. We're going to load it using a driver that's called CSV. We have some description, we have some name, we have some extra parameters for that driver, such as the location of the data and some storage options that are appropriate for S3 in this case. And by doing this, by basically turning your data prescription into code, we can version control it. That's very important. You wouldn't want to have anybody at your organization writing code that wasn't version controlled, and the same should be said for your data specifications. Next, how do I get data? Is it just some abstract thing somewhere that I need to know about? Well, actually, you can, using intake, install your data. This is something that people generally want to do, and lots of packages out there, your favorite scikit-learn or data shader or whatever, lots of these packages have example data sets and their own unique way of loading them just so that you can demonstrate what it is that that thing does. In intake, this is an abstract thing. Now you can have a data package. It includes the specification of the data sets. It can include the code that you require to load that data set all in one place so that you can do something like this. You can say, install some data. You can do this now. And then when you import intake, it will be in this built-in catalog. It will just magically appear there. You can search these things, find the one you want, and do read. That's an option that previously you couldn't really do this any other way. And now you can not just distribute data sets, you can distribute data sets in formats that people don't already know how to read, because you can also include the code and dependencies of all the packages that you require for that specific data. Next, intake cares about big data. It cares about cloud resources. This means that sharing your data sets can be as simple as moving it to a cloud service. The catalog itself can live in that cloud service. Now you can point other users to, here is a URL. It is a catalog. It's going to point to other things that are in the cloud, which is your data, and they don't need to worry about, oh, how do I access this particular service? All these things happen transparently. That's a pretty big step up. Next, and already I mentioned this a little bit, we care about not just your data in the cloud. Why is it in the cloud? It's because it doesn't fit onto your disks anymore. So we want to cooperate with execution environments. We want to cooperate with tools that can deal with big data. So I also work on Dask, so Dask always comes at the top, and obviously, Anaconda cares about Dask too, but there are other tools around that help you with the big data problem, such as Data Shader, which you probably already saw demonstrated today. That's for visualizing big data. It's just an example. There's also Spark. Spark doesn't get mentioned at this conference that much, but lots of organizations use it. Intake has, at the moment, some limited hooks for Spark. We would like to improve the Spark story, but it is something that we care about, that we're working on. And finally, and this has always been true, you might already have something that can deal with your big data on a separate service, whether it's SQL or something else, and it's important to be able to talk to these data services so that you push the computation to them, and then Intake is just the near end of that. It's just funneling in the results from those big data computations. For the Dask story, you maybe end up doing something like this. Every Intake data source, which here I've just called dataset, is going to have, or does already have, a toDask method that gives you the Dask equivalent thing for that data. It might be a data frame, it might be an array, it might just be what Dask calls a bag, so a list of things. And then you can do Dasky things to it, which means if you already have a Dask cluster, this will automatically use that Dask cluster to do your big data computations for you. And you don't need to worry about the details of how it happens. Intake cares about where you run your code. So the new version of the GUI, which is not yet released but will be in the next week or so, probably, looks something like this. There is already a GUI that you can run within your notebook for searching through your data sources. So these things here are catalogs. These are entries within the currently selected catalog. This is the details of that entry. You can run this thing now as a standalone application. And this bottom bit, where you actually show the data, visualize the data, that will be something that is currently functional. You can get this graph. But it will be expanding over time so that you can run a full data investigation application remotely and have your business intelligence people or whatever, have these people just view the outputs. So that is a very convenient thing. Or if you're the person actually doing the analysis, this can be your first step. You look through your data products, quick visualization of the plot to see it, make sure it's the right thing that you want to be working with. And then, if you run this within a notebook, you have the handle to that data set so that you can do your more involved analysis with it. So that's the last part here, but there's more along this story. Obviously, I just mentioned this runs within a notebook. It integrates with Jupyter, so that's great because a lot of analysis happens within Jupyter. You don't have to. It's an option. Intake wants to be very flexible. It wants to have all answers to all people as soon as someone comes along and fills in the very small, usually, piece of code you require to integrate with some particular service. It also has its own server, if you want, which means that you can have your the thing that tells you what your data sources are. That can be a server. There is a very simple intake protocol that talks to the server, and then if you customize the server to your own needs, you can handle a lot of the issues that IT managers care about in that server, such as authentication, and then having authenticated, which sources is this person allowed to see? You can actually filter those when they make their request to list the current data sources. You can actually stream the data through the server too. It can be your single gatekeeper of data if you want. And a little bit more on the last thing on security. Intake has a templating system so that you can fill in various values within the arguments that you're going to be passing to your to the function that actually does the data loading. You can fill those with templating from the environment or get information from the user. The server auth I just mentioned, so you can run that on a remote service. Which means, and we have just a proof of concept of the last point, but it is something that for every single sign-on system that people might have, you can develop these things quite easily. Something that will take the user's identity, pass it to another service, and that service is going to tell them what data they can get or give them further credentials so that they can then piggyback and go to the service itself. That is something that is definitely on a organization by organization basis because those systems are always very complex, but using intake itself is simple enough that you can always do this. And there are more of these. I'm not going to go through, I've spoken for quite a while already, and I've shown you text, I've spoken words. There are lots of additional features. I don't just want to reel off all of the things that intake can do. The code base in intake is relatively simple. It's really easy to add extra data drivers for some given type that you haven't seen loaded elsewhere. I will mention these briefly. The data catalog is a list of things, but those things can themselves be catalogs. So you can have a nesting, which means you have a natural hierarchical system, and you can use this hierarchy to partition all of your services of data as you see fit if you are the curator of that data. You can say, these are the different departments of my company, and they all have different catalogs if you want to. Or you can partition on some other, these are different types of data, different customers, whatever you want. And these sets of hierarchical catalogs can all be independent of each other so that you can search whichever one is appropriate for your particular job. The visualizations, you've seen the PyViz stuff, I think, already. Intake plugs into that, so you have those capabilities for free. The catalogs that you access might actually be populated at runtime from some third-party data service. This can be as simple as, hey, SQL Server, what tables do you know about? Each of those tables is a data set. That exists, you can use that now. There are other things. We have some example ones of people who are querying Mongo database, where Mongo has all of the details of all the data sets, all of their characteristics. You can, using intake, you submit a query to Mongo. Mongo gives you back some data sets, and those appear to the user as normal intake entries. So that's pretty powerful. There's searching, and finally, you can actually, when intake was started, we said intake does not write, it just reads. Intake now writes also. You can transform your data into a local copy in some performant format that's appropriate for that type of data. So for data frames, which you're probably most familiar with, that would be Parquet as the #1 format for efficient tabular representation. You say persist, now you have a local copy. This local copy will live a certain amount of time that you specify. You will use the local copy until it expires, and then you will update it from the latest, from whatever slow service that data is originally coming from. Or you can transform it into something that you put in a shared space. It will also generate a catalog to that entry so that you can share that catalog and other people can use this more efficient form of the data set wherever you've put it. So that's pretty powerful too. Okay, the point is intake does a lot of things. It's a little bewildering. So I've gone through a lot of things, and really what you need to do is try it. The point is, of all of this, all of the things that you're coming back to the roles that I mentioned before, these people have certain requirements of how their data scheme is going to work. The analyst, the data scientist, wants to know which is the right data. How do you get that data? For that data, what is it like? How do I then put that into memory or onto a cluster? And how do I view it? These are all things that intake does. Similarly, from the curator's point of view, the person that actually creates these catalogs, they want to know, how do I tell people what the data is? Well, you write a catalog, you describe the data, you put that catalog in a place where people can access it. Formats and options, that gets encoded into there. So if you're the one that understands what the implications are of using one particular storage format versus the other, then you're the right person to make that choice, and you encode that into your catalog. If later you change it, you can update the catalog. You don't need to change the workflow of the people who are using the data. And this last point, to actually direct the users, well, you don't need to. It's just intake.read.toDask or whatever. There's a small number of these methods. The users don't need to know more than you look at the catalog, you find the thing that you need. IT gets some additional tools in here. I mentioned these, access control, authentication. These are optional add-ons. You don't need to do these things if you just want the simple intake functionality. But you might want to, and particularly as data comes in, it's very natural to want to keep I'll call catalog in the old sense, like you want an inventory of all of the data as it's coming, so you may as well use an intake catalog in the strict sense for a description of what that data is. And then finally, the bit that I actually demonstrated, which is you don't want people including their credentials in your code, so intake cares about that too. And finally, I'm a developer, so I don't know how many of you are actively writing library code, but intake provides a framework within which you can write the nuts and bolts for actually getting bytes into memory. You will need to write some custom stuff if the library doesn't exist for some particular new format, but intake gives you a structure within which to express these things so that you don't need to do much extra work at all, and these data sources become things that users of intake will be able to use without them having to learn your particular library. That's very convenient. Final point, lots of things in intake are plugin, including the auth, including the drivers, including a great number of things. So if people want to be involved, and I hope you do want to be involved, then it's really not difficult to do that. Okay, as I said, I'm keeping this short, so I will leave you with a summary slide, and we'll have about a full 10 minutes for questions, comments, discussion. There is a couple of microphones that will do the rounds for those that have written down all their questions as I've been talking. This will be my last slide, just to reiterate the main points. Intake, from the user's point of view, is just a really convenient API where you do the same things regardless of the type of data that you're trying to access. That's already a big win. But actually the cataloging, where you get to express what your data sources are, basic descriptions, arbitrary metadata I didn't even talk about. Intake cares about metadata, it's in there. That's really where the power comes from. You separate out the people that are going to be using the data, the people who maintain the data stores themselves, and the people who manage the system. These are separate concerns. It means that each of them can get on with the job that they're supposed to do and not get tangled up in, here's this particular data user that requires all these changes, requires IT to get involved, requires somebody to write extra code just for them. This is all in the context of your data moving to big cloud infrastructure, to deployed clusters, to Dask, which we love, and it takes a natural place in that system. It's really easy to make intake into what you want it to be, so actively seeking people for new drivers for all of the data sets that you might happen to have. There's the server, and all of this takes part of the Python, PyData ecosystem, which we're all supporters of here. So that's it. You should install. You can install from CondaForge. You can actually now install from the Anaconda main channel also. Come to the GitHub pages, issues, PRs. Please read the documentation. Get involved. That's it. Thank you.